My teaching career started out when I taught English as a second language in South Korea. I did that for 3 years, and then during that time, towards the end of my time in South Korea, I had an opportunity to study for my master's degree, and it was actually in science, secondary science, specifically biology. And while I was finishing up my master's degree, I came back to America to do the practical part of it, and I had an opportunity to be introduced to a tech startup company in Bellevue, which is where all the Microsoft and Amazon people are at. At the time, I didn't really remember how to code. I took coding like 10 years ago when I was in college, but really a lot has changed, and I didn't really know or remember how to do any of the coding stuff. So part of the interview process with that, I was given a coding assignment, although it was in Scratch, but I just had to kind of mimic what I saw on the screen with my own code. And I did the assignment, turned it in, got accepted, and I started teaching coding to elementary school kids using Scratch. And I did that for about 4 years. And that evolved from teaching Scratch to teaching Python, Arduino, processing, Unity, teaching HTML and kids how to make web pages. A story that I can think of is one of the biggest success last year was for us to work on that inventors unit with the 5th graders. So it started out with just small group learning, and that led them to teach other 5th graders on how to use SamLabs. And I think having students be able to choose what it is that they want to do or what it is that they want to learn and how they want to learn it is really, really important, because no one solution could fit like all students, right? So I think when they are inventing, they get to collaborate with each other, and they get to talk about their ideas, and they get to teach each other something. For example, I hear a lot of excitement, and I can help you with that, or let me help you with that. Let me show you how to do this, or what do you think about this? Or, I disagree with you, or I agree with you about certain ideas. So I think definitely for that project, it really stood out to me. And it was really unique, and the result was really great because we had students that created inventions such as like a musical instrument, an airplane, and many other inventions that you wouldn't think is capable of for a 5th grader to make, but definitely with SamLabs, it kind of provided them the tools to make their ideas come true. So like I was saying before, I think for a lot of students, coding is such an abstract concept. Like they can only see what it is on their computer and they can't touch. But I think through SamLabs, you're able to code something, and as you can see the result of your code with a physical interaction, like a light being able to turn on, or you press a button and it reacts to something physical. So I think that's really special for kids who need that kind of validation for something that is software based. There's a lot of products out there that's similar to SamLabs, or it offers physical interaction with, or physical components with coding. The reason why I choose SamLabs is because, well, SamLabs is pretty heavily focused on coding concepts, because I'm really passionate about computer science, and the whole curriculum at my school is focused on computer science, and I want to build their computer science knowledge, regardless of what it is that we do. So I think SamLabs definitely fit that profile. Is very heavily focused on computer science, and the pathways to learning computer science is really great with SamLabs. It's not an afterthought. And I guess one of the most important reason is pricing, because we all struggle with a budget when we're working in education. And I think SamLabs hit that spot where it's not that expensive to get a classroom kit. And to get started with 25, 30 students or so, in your classroom. So I think budget-wise, it was really the right fit for us. And in terms of product design, I feel like SamLabs, I mean, I have not had a component break in the last year. So that's really impressive. You know, having fourth graders and fifth graders hold a component, you know, drop it, do all sorts of things that I might possibly not see them do. But it's surviving, the components are surviving pretty well with the usage of kits. So I think that's really, really great. And the user interface is really awesome too. Overall, I would say the logistic of connecting a wireless component to an iPad or a computer is pretty easy. I would say once you teach the kids how to do it, they know how to do it, and it works pretty consistently. I haven't had really any major connection issues where nothing shows up or, you know, you can't find the components. So it's overall been a really good experience. And yeah, SamLabs is a really good fit comparing to other products out there that are similar. Yeah. Well, whenever you use a product that's new and whenever you have like a large classroom, I think it's difficult to just roll it out with a large group of students. And it was my first time ever teaching it to fourth graders, especially. It was a little bit chaotic, even though, you know, I had thought of all of these ideas of preparing slides, you know, taking picture of every single small step. But again, it was chaotic in terms of, you know, getting students to learn something new, a new system, especially something physical. And the other challenging thing that I had to deal with was their excitement, because they were so excited. So, you know, it's not a bad thing, but at the same time, it's challenging when they're so excited about something. They want to be able to use that new product that's in front of them. It's like them opening a new toy on Christmas. They can't stand for this toy to not work immediately or not having the instruction to play with this toy. So that was the challenging part. But I think to solve it was to use smaller groups. Like I said before, just being able to teach a few kids and assigning them as leaders and having those kids teach other kids. So peer learning, basically. So I think that really helps in introducing SamLabs to other students, to a large number of students. I think, you know, getting students to like verbally say, this is a conditional, this is a variable. I mean, they know that, but I think they know how to use it better than they can explain it, especially at a younger age with fourth and fifth graders. But definitely, like when I use SamLabs with the seventh and eighth graders, definitely they can tell me what a variable is. They can tell me what a conditional is, because we've been learning about that by taking notes and working on Python and all that good stuff. So they're exposed to that on a daily basis, versus the younger kids, they're more excited about, okay, well, you know, I know how to use an if statement, but I might not know that it's called conditional, even though I've been taught it's a conditional, but they forget, but they care more about what they're doing and what the result of what they're doing. So in terms of assessment, I think that if you assess them, and they might probably get it right in terms of being able to identify, but I don't think that if you were just to ask them out of the blue, like what a conditional is, or can you demonstrate what a conditional is, it might be a little bit challenging for the average kid to do it. Now, there are kids that will just tell you they already know regardless, so yeah. But I think definitely SamLabs definitely helps with that process, because I don't think it's a one grade thing where, you know, you learn this in third grade and you're supposed to know it in fourth grade. I think it's an ongoing process. I mean, I think some kids by third grade, they can tell me what a conditional is. Some kids, you know, by seventh grade, they can tell me what a conditional is out of the blue, you know. So for me, the culture here at this school is an ongoing process for mastering computer science. It starts within the first grade and they work their way up, all the way up to eighth grade. And you know, with different learning levels, different learners, different learning levels, it's just some students get it faster than others. If they're able to get it faster, they can kind of be more independent and work on their own projects. and create their own thing. If they need a little more help, then they are going to follow obviously the projects that I have planned out for them. So that's just what it is.